Welcome to episode 3 of the STEM innovation, the design thinking approach. In this episode, we will cover developing innovations, how to do prototyping and testing. In episode 1, we talk about empathy, generating needs for users such that we can then identify the problems to be solved and therefore generate the solutions which are innovation that is of value to the user. In episode 2, we cover brainstorming. Actually, it's beyond brainstorming. So we cover some tools such as the contrarian approach and the systematic inventive thinking that helps us to think beyond boundaries, to be radical, to have breakthrough ideas. So once we know the customer needs, once we have the brainstorming techniques to generate ideas, the next thing is to prototype and test. Well, traditionally, we say prototype, then test. Now, in the design thinking approach, or the 5 steps process, we have empathize, define, ideate, prototype, and test. So in essence, we are covering the last 2 phases of design thinking. That is the traditional approach, prototype, then test. Now, how about test, then prototype? Well, you think this is going to be not possible? Or maybe we have a new methodology for that. So we will explore both options, prototype then test, test then prototype. Now let's revisit the design thinking processes, the 5 steps methodology, and prototyping. Now what is a prototype? A prototype is an early sample, model, or release of a product built to test a concept or process. Sometimes we call it POC, proof of concept, proof that it works. But again, POC comes in many versions for different people. Those in the lab will say, I proved that it works. So the lab POC, which is not commercializable. Some people say, I have to prove that it works in the field. Then it is commercializable. So what do you mean? For example, if you put some electronics in the box and test in the labs, that is the POC. You want to test that it can detect, let's say, read a card, detect a RFID tag. But that's only in the lab, where it's aircon, there's no humidity, there's no interference. But if you take the box and put it in the field, in a football field, under the trees, to detect, let's say, a card having a RFID tag, that is entirely different, right? Because there are interference, there are environment factors, there are other people moving around. So the proof of concept, therefore, is in the user environment. Obviously, we want to prove the concept in the user environment rather in the lab. So the prototyping, therefore, has a wide spectrums, and we have to move through each part from the lab to the field in order to have an innovation, which is a product that can be used by the customers. So for example, many years ago, I worked on dialysis on the go. And this is the concept we are looking at. I talk about dialysis of the machine. And we say that, okay, how about we build something just to illustrate the person can have a wearable machines and move around. So this is one of the first concepts when we know that they actually can hold it in the hand. We show that it can hold in the hand, it can open it into 2, and then they can wear it as a belt. That's the first concept. Would it work? We test on people. It becomes very bulky. Well, eventually, it becomes a product that is a single machine that can hold in the hand. As illustrated, this becomes one of the final prototype that we built, that we tested out in the field. So how do we do that? Well, the first thing we know that the patients, they need it to be light. So this is a 1 kilogram machine. Well, we have tested on 10 kilograms, 5 kilograms, patient wear a backpack or put it on something like a computer case, but it's just too heavy. But 1 kilogram is just nice. They can wear it at a bag, sling bag, and walk around. So that's the prototype. Secondly, we have to test on its usage. And how we do that? Well, we have the controller and the machine. We plug it together, and there's a click sound here, and there it sits in, and there's fully automated. We have to test such that the patient will just hook on to his peritoneum, which is the tummy, and there wear it as a fully automated machine. During the prototyping, we actually test how many lights are there. So we put 3 lights, power on, in operations, warning signs. However, during the testing, we discovered that the patient, and most of them are seniors, doesn't have very good eyesight. And we cannot afford to have very big LED lights. And there's a problem because they are unable to discern the lights. So we thought, let's forget about the light. Make everything fully automated, right? When you plug on the machine, it will sense, it will turn on. When it's end of operations or when it is having errors, then one light will come up. But then we realized that the light really is very difficult, and therefore we put buzzer sound such that the person can hear. But good, so that's the user need. But we also, regulation-wise, that is also very important to understand that for any device, you cannot just plug in and automatically it runs. The user need to initiate the action. So at the end, we only have one button here, which is to start or to stop the power. And that's what we mean by prototyping, to understand the user needs, bring them into a breakthrough ideas, test it, not on the real device, but the simulation of the real device on the user needs, and give the customers a good experience that he can actually play around with the eventual product. And that's how these prototypes comes about. Well, the prototype is also a term used in a variety of contexts: semantics, design, electronics, and software programming. Depends on what you're working on. We use it to evaluate a new idea. Through brainstorming, you come out with 5 ideas, 5 breakthroughs, 5 radical ideas, and you have to prototype every one of them. But if you build every one of them, it will be very costly. And therefore, we need the prototype to be as, I would say, frugal as possible, and to test it, not having the real thing. So to evaluate this new design to enhance precision for us and the user. Now you look at this. Well, we can recognize right in the middle there's a handphone. And then we have the pictures of the various screens. This is what we know as wireframe. Well, mobile apps are such a common thing, right? So a lot of people develop apps. And even if you do not say use apps as a single item, now there are a lot of IoT devices, there are a lot of machines where you can check on the conditions of the machine, you can control the machines using apps. So it's rather a powerful technique for us to learn. Now, what's this called, right? So we can look at here that the resolution of prototypes, not necessarily it must be exactly like the real one, right? So we can look at it from the angle of fidelity. Is it high fidelity or low fidelity? Well, like hi-fi, right? Is it really precision? Or is it just to illustrate a concept? So when in the earlier days of testing and prototyping, we want to illustrate the concept. So we will definitely start with low fidelity, just to test whether the concept works. So for example, the low fidelity device or prototype will be, in the case of apps, the wireframe. So you just want to test, and you can draw it out. You can draw it on a piece of paper and paste on the handphone. That's fine, all right? Just to test whether it works. The positioning, the logo, the usage. And we have multiple pages. You can even have multiple pages of it, and you just tear out screen by screen to let the user go through the experience. Now, once we are okay with that, then we want to move into something like a mock-up. It doesn't work like the real apps. But again, it is a much more refined, a higher resolution than the wireframe. So we can test on more users. And then finally, we come to the high fidelity prototype, which that we have the processing and everything behind, but not the full features product. And there you have the way that we thought go through the whole process of testing and prototyping, which are integrated together with more iterations, wireframe, mockup, and prototype. Well, for the physical product, it's going to be the same way. You can use a box to represent, a foam to go into a mockup, and then finally come out with the real device. Printed, high resolution. So the other way to look at it is whether it's physical or analytical. And in current world, especially with the advance of digital technology, the virtual reality, augmented reality, immersion, there are lots of opportunities that we can use technologies to illustrate. For example, we use 3D printing. Not necessarily must print the thing. When you are drawing on the computer, it is already an analytical prototype. So let me show you what we have done. This is ExoGlove. It is a software or soft robotic technology that can be controlled, that can be used to control the gloves. And we use it for rehabilitation. And you can see that we go through a whole series of prototypes and drawings just to illustrate how it works, and then finally come up with the device. Now, from Ulrich and Appleton book, they have helped us to classify the prototyping into the two axes with 4 boxes. Firstly, can it be physical versus analytical? How about focus and comprehensive? So, example, you might want to check on a feature and that you want to be analytical first. And most of us, if you are technical, or even if you're not technical, you can easily learn 3D printing, and therefore you can do your 3D CAD model, even for secondary school kids, color rendering, FEA analysis. So these are simulations and analytical model. Well, you can also take the 3D printed model and actually build it into a physical model and then let the user feel it and test it. So moving from analytical first to physical. And you can even then move on focus to comprehensive, which means you test on one feature and then test on the system. And we can see that actually from the CAD model to let's say a wheel to a foam model to eventually building the whole hardware. All right? And in that sense, most of the times we'll start from focus and analytical, and then move to focus and physical, and then to focus, physical to comprehensive. So the purpose of prototyping is to learn. Answer questions about performance and feasibility, proof of concept. Well, the second one is to communicate. So we learn, but we also need to communicate. Who do we communicate to? Demonstration of the product for feedback. demonstrate to the user, demonstrate to the community. And I think it's very important because sometimes people cannot understand if you try to explain to them the concept or is on computer drawing. Sometimes they need something physical. So 3D physical model of style and function is really useful and powerful. And then we can use it for integration to combine subsystems. So you have different parts. Let's say you have a flying car, right? You will have the propellers, you have the seats, you have the motors, and how to put them together from subsystems to fully integrated system to test whether the integration works. Alpha or beta test model, putting the whole thing together as a product. And of course to check on the milestones, all right? The goal of the prototypes allow you to check on the development team schedule. Well, the physical and the analytical prototypes, what are the differences? Physical, of course, is tangible. It may exhibit the model behavior, and sometimes not necessary, depends on how much intelligence or smartness we build into it. And it's very good for communication because you don't need people to visualize, they can see it. You don't need them to think, they can feel it. Analytical models are mathematical model or simulations. It can exhibit behavior because right now most of the software are pretty smart and they can actually say, okay, we put two things together and it really works or not. In fact, a lot of aircraft nowadays are built by analytical models. And when they assemble, they are no more being prototyped, they are just built for flight. So for example, from the book Outreach and Aperture, iRobot Petpop mobile robot itself. So this is a robot, and you can look at the physical prototypes. You can have the wheel testing. This is a focus, but physical testing. This is the looks alike. This is a drawing, or you can the CAD model, and then you have the sand test, which is the real POC test in the field. You have the analytical model, 3D CAD modeling, finite element analysis, the FEA, to see whether it breaks or not, and then the dynamic simulation model of how it works. All right, so it depends on the amount of software simulation tools, the expertise that you have, you can then progress to different stages of prototyping. And this looks at the other axis of focused prototype versus comprehensive prototype. And I'll let the slide speak for itself. And we put everything together. So a comprehensive prototypes will look at, firstly, the technical or market risk, is it low or high? Then the cost of the comprehensive prototype, is it low or high? And I think as far as we are concerned, when we are doing prototyping, we want to keep the cost as low as possible before we build the final product. So what's the prototyping strategies? We use prototypes to reduce what? Uncertainty. We're not sure whether this thing works. This is what the customer likes. We make models with a defined purpose. We want to test something on that. We want to consider multiple forms of prototypes, from a foam to wireframe. Choose the timing of the prototyping cycles. What are you trying to do? You're trying to learn, you're trying to system integrate, or you try to communicate. You plan time to learn from the prototype cycles as much as possible. So there are many rapid prototyping methods. Most of them are additive. That means using 3D printing. They build parts and layers based on the CAD model, which is really nowadays very common and popular. And the techniques that are available are SLA, stereolithography, SLS, selective laser sintering, which are all powder-based concept. So it's just like if you watch Jurassic Park, where there's this jaw of the dinosaur, when they print it layer by layer, and the guy put his hand into the powder, basically flour, and pull out that mouth portion of the dinosaur. That is what they call SLS. Well, we can use laminated object manufacturing, which lots of people don't use, but it's just papers that are sort of stacks of papers glued together. But 3D printing, what we call FDM, field deposition modeling, which is very, very common nowadays, all right? And we get better every year. We get better resolutions and also more flexible materials. We used to have materials that are hard, so like PVC materials. Now we have polymer materials. Well, in the advanced stage, we can even print tissue, and I have a project that involves printing of medicines, which means print not using high temperature but room temperature. So there are many materials that are available for you to do the prototyping nowadays. So obviously virtual prototype is a very effective way and an important skill for us to catch up. So 3D CAD modeling allow us to fit the example. So we have parts here, part B, and put it together. We can check the manufacturability, and we send it to the production line, look at the form and style, look at the kinetics, the movement, and of course the stress, whether it break or not. We can do crash testing. So there are actually lots of simulation software that allow us to do virtual prototyping and testing. And that's, I think, becoming more and more user-friendly, more and more comprehensive in terms of analytical power and simulation power, and we think we should pay more attention to it. Well, the traditional prototyping methods, CNC machining, these are not the additive, these are the subtractive, which takes a piece of material, whether it's metal or wood, and you just cut away by milling, by drilling, or rubber molding. So you can use foams, and of course, kind of expert skills. I'm going to show you a case on a prototype that we have done together with one of my associates. Well, he has an idea to grow plants indoor, but in a controlled way. And this is what he comes up with. Typically, growth pole. Well, so basically what you have is you have these plants that grow from the pole and is vertically, and you can stack it up. Now, so what is the first prototype? Well, the first prototype is basically 3D printed. So you see, this is the grow pole where we print it this way. So one layer by layer by layer, and you can see that actually there are all the boxes here for the plants to grow, and there is this is the cover, so to hold the grow pole, and you can stack it. So it's now a Kickstarter or crowdfunding campaign. That is the prototype that we done in-house. Well, if you want to look at the production unit, this is eventually the concept that we come up with, which is a sheet of plastic that you can fold with the arrow edges and form into a grow pole. And the final product is this, the grow pole, and this is how it looks like. Earlier, we talked about prototype then test as part of the design thinking phase. And I posed a question. How about test then prototype? Does it mean we will get better answers? Make it lean or cheaper as part of the process? So I'm going to bring you a new concept to prototype a product concept, right? And this is something that we have been working on in the industry, especially in new ventures. So first we need to understand the concept of minimal viable product, or MVP. Now, Eric Ries in the Lean methodology or the Lean Startup book mentioned that the minimum viable product, the MVP, is that version of a new product which allows a team to collect the maximum amount of validated learning. maximum amount, validated learning, about customers with the least effort. So maximum amount of validated learning with the least efforts for the MVP. Well, so he proposed something called a build, measure, learn. Build the prototype. But do you really need to build the real thing? No. The concept is not to build the real thing, it's to test individual features. So what can you build? Well, it could be a simple test that we can talk about. Measure. You must collect data, and that is very important because we need to be evidence-based. So we can conduct a survey, and that's called building something. Measure it, and then we learn from it. Maybe the pricing, maybe the features, maybe the weight, maybe even on the button. So therefore, in order to do that, we have to think about something called the value proposition. And it's in sync with the design thinking approach that we talk about. Well, so the value proposition is definitely describing the benefits a customer can expect from a bundle of products and services. So we extend beyond just product, right? It's a comprehensive offering for the customers, right? And you put yourself in the customer's shoes, which is design thinking. And therefore, we should have a persona. In design thinking, we have a persona, and we map it through its journey. When we map it through its journey, then we discover certain problems, and based on the problems, we can then decide what kind of jobs this person needs in order to solve the problem. And therefore, the value proposition canvas is actually a prototyping tool for the product concept. So we start with the customer profile. Well, the customer profile is the persona. It's the market segment that we want to work with. And then we ideate, right, after defining the problem. So the customer profile will definitely have the problem, which is ideate with the product. And the product is called the value map, or embedded in the value map, which we call the value proposition. So that's where value proposition canvas comes in. Now, for us, for understanding customer, we have come across this concept of Henry Ford to say, if you have asked people what they wanted, they would have said faster horses. Again, people would not be able to think about something different from what they are doing, or rather they were not going to imagine about it. So how would a person who is riding a horse for his life figure out that he really wants a car? There's no chance, right? But as an inventor, we always look at, really? Is it about horse? Is it about car? Or is it really about traveling from one place, point A, to another place, point B, A to B, with comfort, with safety, possibly with efficacy, speed? It's not about a horse, but a horse is the product of that time. And we are inventing a new product called a car, which the customers or the user probably won't understand until they see one. And this is again by a Harvard Business School professor, Theodore Levitt, marketing professor, very famous, that give you the real needs of a product concept, right? That when you are having a hole, people don't want to buy a 1/4-inch drill, they want a 1/4-inch hole. So if we talk about new product concept and we're always looking at the drill, then we are always looking at how to improve the drill, how to make it stronger, how to make it more precise. But really, it's all about the hole, not about the drill. The drill is only one product to produce the hole. In the modern world, we can produce the hole in many ways. We can use a laser to lace out the hole. Of course, we can use a punch, right? So there are many ways to do that. Even we can use a high-speed water jet. The question is which is the right way or a better way. So we focus on the needs. And therefore, in order to focus on the need, there's new concept by the late Professor Clayton Christensen from Harvard Business School, which talked about disruptive innovation, and he talked about the concept of jobs. So if you have a problem, you need to resolve that problem. So what are the jobs? and he look at the jobs is what the customers are trying to get done in their work and in their lives. So there are three categories of job: the functional, emotional, and the social. Well, functional things are quite easy. It need to be get done, right? So it's like a shopping bag or office bag. Let's try to talk about office bag. If you need to go to the office, you need to have a bag. It must be large enough, and it must carry sturdy stuff, right? Computers. So it must be sturdy and large. That is the functional, for you to put something in and bring it around. But it also has something called the emotional jobs, what you like. Well, you go to the office, some people prefer not so flamboyant color, black color. Some people love maroon color. So it's very individual. It's an emotional job. How about a social job? Well, you do not want something that is animal hide, a cute animal for the bag, or you may want it to have a certain design so that it is in sync with the profession, the industry, the vocations you are in. So the design could be a social job. So what we want to do is to decompose the jobs into pain and gains. Let's talk about pain. Pains describe the bad outcomes, risks, and obstacles related to the customer job. And let's talk about functional job, the bag itself. If the bag need to be at a size that we can put a laptop in, and it's not big enough, and it's not big enough, the current product is not big enough, then obviously the customer have pain. You will have laptop protruding from his bag. Or the bag need to have to be sturdy enough to hold a certain weight, let's say 2 kilograms. So what does it mean, right? If the bag can withstand only 1 kilogram, then the bottom will break. So that is a pain. So we need to resolve that. So and moving from jobs to pains, we become much more detailed and best quantitative. If we can quantitative enough, we can further decompose and understand. Then the gains. The gain describe the expected benefits the customer are seeking. So for example, the expected benefits of the color, a black office bag. So it is an emotional jobs that can be a gain. And what does a gain mean? It means I feel great because I like black color, all right? And then even it's the design. If the design is in season, I can blend into the surrounding. Nobody want to carry a supermarket shopping bag into the office because it can't blend into the office environment. Neither do you get a briefcase and go to the supermarket and stuff your vegetable inside. It just doesn't blend. That is the social job. So with the categories of functional, emotional, and social jobs, we now are allowing ourselves to go into further details of the job. Be as specific as possible. Well, and therefore, it helps us to complement the problem definition, make it better in the design thinking process. Now we ideate and come up with lots of ideas, lots of breakthrough ideas, or radical ideas. And how do we know that it fits into the jobs? So what we do is the value map is basically it's a product and services. And it's not just purely a product, right? It's a comprehensive offering. It's a list of all the product and services as value proposition, like safety, right? So safety through a smart light communication helmet. Value proposition is safety. The product is the helmet. Like the dialysis machine, the wearable dialysis machine, the value proposition is freedom. But the solution is a 1 kilogram wearable battery operated machine. Now, same as just we described on the jobs, the product and services or the radical ideas that we come out can be categorized, further go into details into pain relievers, describe how products and services elevate customer pain. So with the customer pain, we have pain relievers. If a customer has a headache, we have painkiller. So pain relievers to pain. It's a one-to-one matching. And that's why we need it to be very specific, because we know that the product has to be specific. So for example, let's talk about the office bag. The office bag need to put a, let's say, a computer inside, so it must be sturdy enough to carry 2 kilograms. And therefore, the bag that is designed must have a specification of features of maybe 2 kilograms or 2.5 kilograms. That is the minimum, else you are not addressing the pain. If the things that you design or the prototype has only 1 kilogram, obviously the customer pains are not elevated. In that case, your pain reliever doesn't work. Then, same as the pain reliever, we got to create gains. Well, let's take the bag as an example. The office bag, the customer wants black. Well, you can then say, with the office bag, I can offer black. Maybe what the customer wants is not just black, right? It may be subdued color. So anything of a subdued color, not shouting, will be great. So you have maroon red, right? Black, dark brown, anything dark blue. So things that doesn't shout in the office will be again creators to fit that low profile feeling of the office bags. And then we put both of them together, and we can see that if we are able to list down the pain relievers, to list down the pain creators, and match them in terms of priority for the customers, pain and gain, then we would have achieved a product market fit. This is the market, this is the product, and a product market fit. And that's how we design this product, right? So for example, if I have a functional job, and the functional job has F1 and F2 that I can further decompose. It's a bag, a certain weight plus a certain size. And then an emotional job, color or design. So this is where you understand the customers through the jobs. Of course, you can have a long list, but what we are really interested in new product is we are unable to do everything, right? But we can do something that is essential for the customer. However, the customer will definitely have a long list, but it's okay. We can take time to meet the needs. But the important thing is, what are the essential needs? What's the minimum set of features that the customer require? Firstly, for office bag, it got to be simply weight, volume, and simply design, right, or color. And then we propose a product, which is the value proposition. So what's the value? The value is a professional-looking office briefcase, let's say. And we make it black, or make it subdued color, dark brown, dark blue, so that this value proposition of color can meet the professional look of the office worker. One-to-one matching. And then we can, from the bag, come up with the value tool. And the value tool could be about the weight itself, how far it can carry. All right? And therefore, in essence, what we have is what we call a minimal set of features that can address the essential customer needs. The minimal set of features that can address the essential customer needs. What we call the MVP, the minimum viable product. So now we understand what is an MVP. Let's try to take an example, all right? The MVP is definitely the product or service feature needed to deliver the gain creators and pain relievers. It does not meet all the pains and gains that the customer wants because it's the minimal set. All right? And therefore, by achieving product market fit, we can actually look at a couple of matters that are important, right? Because when we work with persona on a real person, we have a problem, we have a solution. That's design thinking. And then we turn that person into a market, a sizable market that we can launch. And who's the beachhead? It's this guy. It's the persona that has the problem. And the product is differentiated and certified. Obviously, we need certification to bring our product into the market. So let's take a look at this example of a minimum viable product. You define the prototype. We can say, first, like the handphone example, the apps, we have wireframe. It's almost like a wireframe, right? It's a drawing. You can do it CAD, but of course I can sketch it easily. All right? Now let's take a look at really what's the purpose, what's the job of a donut. Well, actually it's not a donut. The donut is a product. The job that the customer wants to do is breakfast. And one of the things of the breakfast is to fill the tummy, right? So the job is breakfast. And then if you look at the pain, you need to fill the tummy. That's a pain. If you don't fill the tummy, you're going to go hungry, and you'll be like grouchy when you go to the office. But it's not just filling the tummy is the MVP, because you cannot just stuff things into your mouth. You also want to have minimally food that is nice, right? So what's food is nice? So it's a gain. So you need to have some sugar or something nice. And therefore you can talk about, all right, I have one pain and one gain. First, it is nice to eat. Second, it must be filling. So that gives you the job of the breakfast. Now, you can have breakthrough ideas. And the breakthrough ideas could be the nasi lemak burger, right? Where the rice in the burger will fill your tummy, and then maybe the chili, some nuts will make, or otah will make you feel, or fish paste will make you feel nice to eat. That's one way. So there are many offerings or product ideas. Nasi lemak, nonya kueh, waffle. And one of the products that we can come up with, obviously, is donut. Now let's take a look at the donut, right? If you think of a donut and you park it at the value map, which is the value proposition is to fill your tummy, but the product is a donut, what is pain reliever? The donut has a dough, has this bread, ring of bread, easy to hold. And that amount is enough to feel the pain of hungry, right? You need to fill your tummy. So there's a one-to-one match of pain reliever to the pain. The quantity of that donut to hungry. But the minimal set that the customer wants is that, hey, I also need it to be nice, right? So nice. The donut has sugar. So the sugar on top of the donut create the gain creator, which is the gain is nice, right? So minimal set is nice and take away the hungriness. The product is a donut with a certain quantity of dough plus sugar. And that's a product. And therefore, you prototype the concept, you define the MVP, which is where you can test. But we know that the customers have other needs, right? Beyond that, they want to they want it to look nice, they want to have variety of tastes, they want many other stuff, maybe they even want it to be healthy. So you can see that the final product has a lot more features. And therefore, for us as innovator, we have to focus initially on the MVP and then finally come out with the product. So in that sense, we are able to test this much earlier, to test before we build the prototype, to test the features, and those are hypotheses. So in the lean methodology, we build hypotheses. We can draw this, and then we show to the customer as a survey. And that experiment which is the building phase, which is the drawing, can tell us whether the customer like it or not, which is evidence, and that we learned, is this a possible MVP? We conclude episode 3 on prototype and testing. From the design thinking phases, empathize, which we cover in episode 1, brainstorming or ideate, beyond brainstorming, which we and define problems that we cover in episode 2, and lastly prototype and test, which we cover in episode 3. So I have illustrated the traditional way of looking at prototyping, the 3D modeling, and also bring you a concept of the minimal viable product and how we can test features without actually building anything at all. So it's important for us to maybe look at things and say, instead of building, prototype and test, maybe we also have a new concept called test, then prototype. I leave it to you to explore. We have covered the full design thinking process of 5 steps, episode 1, empathize, episode 2, on define and ideate, episode 3, and prototype test. Now we're going to string this whole thing together and tell a stories. Narratives are very important. What kinds of narratives? How do we do it? How do we project the customer experience? And I think that, if done well, allow us to build a very good design thinking process for a great customer experience. I look forward to see you in episode 4, storytelling and narratives.